So our next speaker is Neha Ram. Neha grew up in India and later graduated from Carnegie Mellon University. After that, she worked as a software engineer and came to Scripps to follow her passion for marine life and to pursue a career in marine conservation. She wanted to leverage her software technology background and learn new GIS and R skills, which she did while she was here. Her goal is to build tools and apply them for marine protected areas and ocean conservation. So the name of her presentation today is Distilling an Ocean of Data, a compliance tool to inform MPA management by filtering data into useful indicators.
All right. Thank you, Samantha, and thank you to everyone who's watching this remotely. My project was inspired by my time in the Maldives. In 2018, I was fortunate enough to visit this island nation that is located in the central Indian Ocean. I visited the South Ari Atoll, as can be seen by the arrow on the map, and this area in general is a very popular tourist destination. I volunteered with the Maldives Whale Shark Research Program, an organization that has been collecting scientific data on a distinct population of whale sharks for the last decade or so. This whale shark population aggregates around these islands and is native to the region. They're located inside a marine protected area that's also filled with several other megafauna like mantas, dolphins, turtles, and of course, these gentle giants. This Indo-Pacific population of whale sharks has been assessed as endangered by the IUCN. And the Maldives Whale Shark Research Program has been collecting data on them for over a decade in collaboration with local stakeholders, such as dive boat operators. This data was used in 2009 to create the South Ari Marine Protected Area. Sampa, as can be seen on the map by the pink region, has a boundary that extends 1 kilometer seaward from the reef crest of all of these islands. When I came to Scripps, I learned more about marine protected areas. I learned about their science, I learned about their policy, and about the importance of bridging the gap between the science and the policy. So far, I had seen the science that was being done in the Maldives. Now I decided to take a look back and see what the policies were like for Sampa. I realized that although Sampa had been designated as a marine protected area in 2009, there wasn't a management plan in place yet. This meant that there was weak to no enforcement and monitoring, which had led to several issues, such as high traffic of vessels, overcrowding of tourists, and speeding within the MPA that has often led to whale shark injuries. This image shows a typical whale shark encounter. When an animal is sighted, there are often 8 to 15, sometimes even more boats that crowd around it, and there are several tourists in the water that usually tend to violate the basic etiquette for interacting with an animal in its natural habitat. When I thought of all of these issues, I started thinking about ways in which I could take the data that was being collected scientifically and deliver it more effectively to inform the policy for creating the management plan for Sampa. This has led to my project, which is the development of a tool that allows this. But in order to develop this tool, there were 2 problems that I needed to address. The first is that there's a vast amount of raw field data that has been collected for over a decade. And in its current form, this data can't be used directly to inform management. The data essentially looks like a large Excel sheet. It has thousands of rows of entries since 2006, and for each entry, there are nearly 60 variables recorded, such as the length and sex of the whale shark, the number of boats and people in the water, oceanographic conditions at the time, etc. The second problem is the lack of a tool to interface with this data in a useful manner. There's a need for a platform that allows us to filter this data, to visualize it, to interpret it, so we can assess the current behavior and trends within the MPA. This is where my project comes in. I've developed a software application that allows us to do just that. Initially, I thought of using ArcGIS because as a software, it has great data analysis and visualization capabilities, but unfortunately, ArcGIS is not freely available, and therefore it's not easily accessible in many parts of the world. Therefore, I've developed a software application from scratch using R. That's an open source programming language. And therefore, my tool is freely accessible and easily available. Using my tool, the user can input certain fields based off of which the outputs generated in the form of maps and data tables, as can be seen on the slide. The user inputs come in the form of time periods. The user can select either seasons, years, months, or days based off their interest with which they want to filter the data. And this allows them to narrow down the data set they're dealing with. The season basically corresponds to the tourist seasons in the Maldives, and therefore there are high and low tourist seasons. If they don't want to use a general tourist season as a field for narrowing down the data, they can also manually select years, months, and days of the week. This allows the user to customize the time frame within which they want to view the data set. The day of the week field is also a very important time frame because different vessels and different people use the MPA in different ways depending on the day of the week. So this can be used in a way to control access to the MPA and generate criteria that might be useful to issue entry permits. The second type of input in the software application is the indicator. Now, the indicator is the most important part of this tool. What an indicator is essentially is a way to take this filtered data and to put it in a context that directly relates to a management need. That is, the indicator signifies what we want to understand from this data. An example is the whale shark behavior during an encounter. This could tell us a lot about the impact of tourism on the whale sharks. For example, if during an encounter, the whale shark's behavior remains natural, that is, it continues swimming, feeding, or even interacting with the tourists, that's considered a positive encounter. But if their behavior has been disrupted or disturbed in any way, that would be considered a negative encounter. And by being able to visualize the data for this particular indicator, we could gauge the level that the presence of tourists and boats has on the whale sharks. Another example is the number of boats that are present at an encounter. If there's a proposed regulation that sets a limit to the number of boats that can be present at the site, we can see through the data how many times this limit would have been violated in the current state. There could be regions within the MPA where there are violations more often, or maybe certain times of the years in which this limit would be violated more often. I'm going to walk you guys through an example of an indicator using whale shark behavior. So initially, the map is loaded with the entire data set, and so you can see every encounter since 2006 on the map, represented by the blue dots. If you want to filter this data down by time frame, we can select a year, say 2020, and the map updates with the points of just the encounters for 2020. Then we can select our indicator, which is whale shark behavior in this example, and we can see that the map has now updated from a blue symbology to red and green. We can go back and compare this to another year, say 2017, and we can see that the map now has an updated set of data points, and it seems like in 2017 there are more red dots than green dots. So what this red and green symbology imply is the presence of a negative or positive encounter, as I explained in the previous slide. So if a whale shark's behavior was disturbed, that would show up as a red dot on the map. And if the whale shark remained in its natural state and was undisturbed, that would show up as a green dot on the map. This serves as a starting point. By selecting a time frame to narrow down the data and by selecting the indicator we want to view, with one glance at the map, the user should be able to gauge the level of positive versus negative encounters. By zooming around in the map, you can get an idea of regions that probably have more negative encounters versus positive. And by playing around with the time fields, we can also see whether certain time periods within a year, within a season, are more problematic. This next step after this initial visualization would be to delve further into the data. This would be done by adding supporting outputs in the forms of graphs that help us understand the data better. Over the next 3 months, I plan on working to develop this tool by adding more supporting outputs in the forms of data tables and graphs. I also plan on adding more indicators to the list that's currently being supported by the software tool. And lastly, I want to allow filtering based on zones. So not just spatial, not just temporal filtering using the time periods, but also spatial filtering based on the proposed zones within the MPA. The zones could be for diving, for recreational fishing, or even for whale shark conservation. And that would give us a better idea on how to propose regulations for specific zones. The ultimate goal is to publish this tool online in the hopes that it could be beta tested by the government. Finally, I would like to thank my Capstone committee for all the help and guidance, Richard Rees, my chair, along with Professor Kasif and Amy Work. I'd like to thank the Maldives Whale Shark Research Program team, especially Clara and Jessica, for their help with the data. And a big thank you to my Scripps family, especially Samantha, Riza, and my lovely cohort for all their moral support throughout the year. And my friends and family that are scattered all over the world, especially my fiance and my dog, to keep me sane throughout this pandemic. Thank you.
Thank you, Neha. So we've got a few questions coming in. First, what would you say are the most important or common problems faced by the whale sharks in the Maldives?
So I think the most important problem that they face is exposure to humans. Because of the tourism industry, there are a lot of boats and people that frequent the marine protected area. And the most common thing is injuries, accidents, to the point that their injuries are actually a form of recognition. That's how we actually end up recognizing them many times in the database. So having specific regulations in place to dictate these interactions would be a great step for their conservation.
And what were some of the biggest challenges that you faced in developing this compliance tool?
Technically, it was a new software package for me, so that was definitely a challenge. But more importantly, developing the concept and designing the application was a challenge, mainly because of COVID. I wasn't able to meet the people I wanted to meet, interact with the people that I wanted to meet. The government wasn't necessarily available for all my questions, and so that kind of made it challenging to anticipate their needs in order to design this tool that would serve them ultimately.
Great. And we have a question from Shivani in New Jersey who wants to know, are there any additional indicators that you plan to add to the compliance tool?
Yes. So currently there's whale shark behavior and number of boats that would be allowed at an encounter, but there are other indicators like every time a new injury was found on a whale shark, every time a new individual was recognized within the marine protected area, and even the behavior of tourists in the water with the whale shark can be quantified based on the data that we have. So including all of these would be definitely the next steps.
And who do you see using this tool and how in the future?
Yeah, so I probably didn't put that in my slide. The main audience for this tool is the government of the Maldives. The idea is to give them a tool to interface with the data that the nonprofit organization has gathered over the years. And the way I see them using it is instead of getting bulky reports before all their meetings and stakeholder consultations, they would be able to just get a link and use that link to access the data, look at the maps, decide that if we want to set a regulation on the number of people that are allowed in the water, what is happening right now with the number of people in the water? And that could help them set realistic goals rather than just pull a number out of the air.
Great. And we've got another question coming in from the web. Could you elaborate on what factors were most correlated with the negative encounters?
So with the example that I gave for whale shark behavior, one of the main factors for more negative encounters in certain periods is the lack of monitoring and enforcement in these waters. So there's no patrolling, there's no monitoring of how many tourists are accumulating near a whale shark, how the boats are behaving around them. And during my visit, I've seen that people do violate these basic etiquette rules. So they swim very close to the whale shark, they chase it, they probably even try and touch it. So basically lack of enforcement and monitoring definitely affects the nature of these encounters.
And then we have one final, what's a comment and a question from Sahil in San Diego. Amazing talk. Great example of fusing science and technology. And they say, how did it feel to swim with the whale sharks in the Maldives? And did that experience play a role in choosing your capstone project?
Yes, it was a great experience. I actually did put the video of that in the slide. That was me with my first whale shark encounter. It took me a lot of time to find the whale shark, which is funny because it's a huge fish. But it definitely made me care more about the environment. Even though I love marine life, it was an experience that made me care about it in a more specific way, to the point where I was inspired to do something more with the organization that I went and volunteered with. So it was an amazing experience, and it definitely inspired this project.
Great. Neha, I want to tell you, you've got more questions coming in, more than we have time for, so I'll just encourage you to work with Risa, who's receiving the questions, and maybe you can email answers back to some of these folks who have more questions
I'll follow
for you.
up.
Nice job.
Awesome. Thank you.